Hello again, Internet. Right now we are going to go over the graphs of sine and cosine. Just basic graphs of the basic functions. And then later we're going to go into the craziness of transformations with these graphs. Okay, so let's start with the graph of sine. If you have the function y equals sine of x, very basic function, this is what it looks like. First of all, it's periodic. That means it repeats every once in a while, a certain period, after a certain period. And that period is 2 pi. Okay, so just like any function in algebra or pre-calculus or calculus, what we have is just a set of numbers. We'll have a set of x values and y values. Okay, so a function is something where we plug in x and then the output is a y value. And we graph that on a rectangular coordinate system. So the graph of sine of x then, let's just start by saying x equals 0. Okay, so sine of 0 is what? Well, if we look here at our unit circle, this angle is 360 degrees or 2 pi, but it's also the angle 0 degrees or 0 radians. And for sine, we are looking, once again, at the y-coordinate. Okay, so the y-coordinate at x equals 0 is 0, y equals 0. Okay, that's easy. Okay, now we're going to go in terms of angles for this. We're plugging in angles for our x. Okay, so the next one, let's plug in pi over 2. Okay, pi over 2, or 90 degrees. Let's just go with pi over 2. So at pi over 2, what is the y-coordinate? It is 1. Okay. For pi, or 180 degrees, the y-coordinate is back to 0. And then, going down, let's go to the next one. 3 pi over 2. 3 pi over 2. Let's see, what is the y-coordinate? It's down here, so it's -1. So we're kind of translating from one rectangular coordinate system to another. And then finally, 2 pi, we are back to 0. So then what does this look like when we graph it on a rectangular coordinate system? Oh, beautiful. Okay, we have a point here at 0, 0, okay? X is 0, y is 0. So let's make a label here. I love labels, especially when they look like little great horned owls sitting on his perch. Oh, yes. Yes, he's an owl. Okay. If you want extra credit, you will definitely want to have that owl there. Okay, let's have a point. Just mark where our 1 is and -1, because we're going to be going back and forth between those two. Okay, so let's go. Our next x value is pi over 2, and that is at 1. So we have a point here at pi over 2, 1. Next is pi, that's at 0, so we have pi 0. Go out one more, that's 3 pi over 2, and -1. 3 pi over 2, -1. And finally, 2 pi 0. 2 pi 0. All right. Now, if we were to graph points in between these, let's take a look. Let's look pi over 6. Pi over 6. Where x is pi over 6, then y, or sine of pi over 6, is 1/2. So 1/2. Just say that. Okay, so if we have the point pi over 6 here, which would be, oh boy, where would that be? 2 pi over 6, 3 pi over 6. It'll be right about here, I believe. 1/2. Could have a point there. Okay, so how about pi over 3? To add a little more detail. Pi over 3, what is sine of pi over 3? It's the y value. So it's square root of 3 over 2, which is, I believe, more than 1/2. So it's square root of 3 over 2. So when we draw this, let's see, pi over 3 will probably be about over, that's 1/3 of pi. It'll be right about here, I think. Doesn't come out very nicely. But it's more than 1/2, so it should be maybe about here. Okay, so what we see then from that is that we have not just a zigzag, but it's actually a smooth curve. So it goes up, down smoothly, not just zigzagging, all choppy. And it continues going. The domain is all real numbers. All real numbers. So it goes on x forever. The range is limited to -1 to 1. So that is the graph of sine, the basic graph of sine. Now let's go on to cosine, and hopefully we can do this a little bit faster. Okay, so cosine is similar, but it's not exactly the same. Cosine is also periodic with a period of 2 pi. Periodic, and the period is 2 pi. So essentially it's a graph of all of the x coordinates of these points. So when we say we are graphing y equals cosine of x, cosx. Okay, so let's say x, y. Okay, start with 0. Oh, look at this. It starts at 1. It starts at y equals 1. So this is where it's really different. It's just kind of set off technically by pi over 2. Okay, pi over 2 then is 0. From sine, it's different from sine. Let's be very confusing. Yes, okay. Pi, x value is -1. And then 3 pi over 2, back to 0. And 2 pi is back to 1, right there. All right? So, yeah, we've plugged these in to this equation, so that gives us the x values of these. So let's look at this. Look up here. Okay, we're just going to do one period of it. Go from 1 to -1. But, so here's how it's different from sine. It starts at 0, x is 0, y is 1. Okay, then we go to pi over 2, pi, 3 pi over 2, 2 pi. Pi over 2 is 0, pi is -1, 3 pi over 2, 0 again, and 2 pi is 1 again. So label these. Labeling is good. Your teacher loves it. I am sure of it, because I am a teacher. pi over 2, 0. Because if you don't have labels, then you could just be arbitrarily assigning points, and you will lose points. See what I did there? Because it's not clear that you actually know what you're doing. And we know you know what you're doing, and you want to show off your math skills. Okay, so make it smooth and continuous, not all zigzaggy and choppy. Okay? And that is the basic graph of cosine. So from here to here is a period. So the exact same thing starts happening to the y values every 2 pi units. And so this is something that's going to happen for the rest of our equations, which we'll go into later, which for me is right now. But for you, check it out when you have time.